Basic antiderivatives, algebraic. The directions say evaluate the integral by finding the antiderivative. Okay, so here's what we need to know. I'm going to adjust the paper a little bit here. This is called the power rule. Okay, and the power rule states that if you take an antiderivative x to the n of an algebraic function, it's x to the n plus 1 divided by n plus 1 plus the constant of integration c. So that's the rule we're going to use. It's basically the inverse, well, the mathematicians wouldn't like me saying inverse for this, of the power rule for derivatives, okay, which is n times x to the n minus 1. It basically goes backwards. And so this is a derivative, and this is an antiderivative. Okay, so we're dealing with antiderivatives here. So let's look at a few examples, okay? And here I have 3x to the first, and so I'm going to add 1 and divide by the new power and add a constant integration c. And that's the antiderivative for that function. That's all there is to it. Number 2, I'm going to rewrite this one x to the negative 3 dx. Now that was not a calculus step, that was an algebra step. Now I can take the antiderivative and I'm going to add 1 to the power, so I get x to the negative 2 divided by the new power and add a constant of integration. Now you'd probably see that written negative 1 over 2x squared plus c. Okay. So now number 3, I'm going to rewrite this one, x to the 1/2 dx. Again, that's algebra, not calculus. And now I'm going to take the antiderivative, I'm going to add 1 to the power and get x to the 3/2, divide by my new power and add c, my constant of integration. I'm going to rewrite that 2/3 x to the 3/2 plus c. And you might also see that as 2/3 the cube root of x squared plus c, of course, which is just how you deal with radicals and rational exponents. Number 4 is a pretty straightforward example, so I get x squared over 2 plus 2x plus the constant of integration c. That was a little off camera, sorry. And if I wanted to check that, I could take the derivative, which is just going backwards, of x squared over 2 plus 2x plus c. And I do 2 in front, so I get 2 over 2, x subtract 1, plus 2, plus 0, which is x plus 2, which works, right? So antiderivatives and derivatives are just backwards of each other. Kind of like inverses, again, but don't say that out loud to a mathematician. Alright, let's look at a few more. Okay, number 5. The integral of dx is just x plus c. And again, if we took the derivative of that, of x plus a constant c, it'd be 1 plus 0, so just 1. And again, I have a 1 there. So that's why that works, okay? So number 6 would be 5x plus c. And again, if I took the derivative of 5x plus c, I'd get 5 plus 0, or just 5. Because the derivative of a constant is 0. Alright, so number 7 is kind of a straightforward problem. 3x cubed divided by 3 minus 2x squared over 2 plus 3x plus a constant. I'm going to simplify that. So we get x cubed minus x squared plus 3x plus a constant. And again, if I were to check that, I'd get 3x squared minus 2x plus 3. Okay, now number 8 is a little bit trickier, so I'm going to rewrite that one by splitting the two fractions, x over x to the 1/3 minus 2 over x to the 1/3 dx. So that one ends up being x to the 2/3, and I still haven't done any calculus yet. All I'm doing is algebra. Minus 2x to minus 1/3 dx. So I get, when I take the antiderivative, I get x to the 5/3 over 5/3 minus 2x to the 2/3 divided by 2/3 plus c. When I simplify that, I get 3/5 x to the 5/3 minus 3x to the 2/3 plus c. And you might want to check my arithmetic there on that one.